Hello to all. Good morning or good afternoon, depending where you are watching us. We are sorry for this 2-3 minutes delay. We have some technical issues that are now solved. So I would like to welcome you all to this presentation, to this webinar from Cecil Tech focused on natural insulation systems, mainly our Isovit and Ecocork systems. Just to explain you very briefly, we will have a presentation. I will present some references and some solutions, and I would ask you to, during the presentation, if you want to place some questions, you can place it by written on the message box in the webinars on the online webinar, and in the end of my presentation I will try to answer as much questions as possible. If I'm not able to answer all of them, I will answer the rest of the questions by email, okay? But feel free to place the questions during the presentation whenever you feel the need to do it. And also, feel free to give us some feedback regarding the video and audio that you're getting in terms of feed, okay? So, without further delay, I will start the presentation, and I'll try to keep up with the schedule. So, just a quick presentation about Cecil and Cecil Group. So, Cecil is a leading group in Portugal, founded in 1930. Which integrates about 40 companies that operate in complementary areas as the concrete, precast blocks, natural hydraulic lime, plasters, coatings, pouring, and of course the production of cement. The company is originated, of course, in Portugal and extends now to other countries, mainly Tunisia, Lebanon, Brazil, and Angola, with activities on the cement business. Regarding Cecil Tech, which is a company within Cecil Group, Cecil Tech is a company with almost 130 years old, with a large experience in lime production. Cecil Tech was founded in 1891. It was called at the time Cimentos Naturais e Cal Cimento, and is one of the oldest hydraulic lime production units still in Europe. Aside from the lime production, we now are producing also natural hydraulic lime, which we use for the production of mortars and also to sell in the market as a premium binder for mortar production. Okay, starting now in the subject of the natural insulations, I would start with a concept called Ecocork. So this concept is based in several concerns, of course, with several focus, mainly the use of a premium binder, which is the natural hydraulic lime we produce, and also, as the name says, Ecocork, the use of durable, recyclable materials, preferably from natural renewable source. Here we talk about the cork. The NHL and the cork together, they represent materials with low environmental impact in its production, and also quality, durable, and energy efficient. Of course, considering the binder, the NHL, we have to look at our production unit, our plant in the center of Portugal, where we produce the NHL2, NHL 3.5, and NHL5 that work as binders for our mortar production also, but also for supplying to the construction sites for mortar production in several countries. These are, of course, the main advantages of the use of the NHL comparing with other binders. Its pureness, because according to the standard and to our production, it doesn't allow any additions, so it's 100% natural with a high free lime content. It's characterized by its CO2 absorption by carbonation, and also the low emissions. So it's almost like a full cycle in terms of the emission and the captation of CO2 when it sets. Also, the gradual development of mechanical resistance. This is very important in the mortars because we want them to gain the resistance at longer term and with slower increase to prevent pathologies like cracks and micro cracks on the mortars itself. Also, the natural hydraulic lime is characterized by its hydraulic and aerial set. So it's a binder that gains resistance through these two types of setting, and it's also a binder in mortars with a total chemical physical compatibility with ancient mortars. Also, it can be applied over several types of substrates with the performance of an excellent water vapor permeability without calcium sulfides, with a very good resistance to salts. Here we talk about durability of the mortars. So when we talk about mortars with NHL, we are talking about the resistance to salt in environments where you have rising damp, you have capillarity, hygroscopic salts, but also to freeze-thaw cycles, which is very important in northern countries. It's characterized also for its natural color for our NHL, and with an excellent workability if used in mortars and recyclable. Okay. Now we get to the aggregates, and here the concept is even more interesting because we take literally the cork from the trees without damaging, without killing the trees, so we are improving its durability even, and we take it from the skin of the trees to use it in the skin of the buildings. So this is a concept of the sustainable construction that we look into with a minor environmental impact possible and with the lower power consumption possible. So as I said, we are using natural durable raw material with the aim to reduce the energy consumption through the improvement of thermal insulation of the buildings. This way we are improving the quality of the internal environment, including acoustic and health benefits. So here we focus mainly on the comfort of the people living inside of the buildings or working inside of the buildings, and of course, more and more important, the health benefits in terms of the air quality, internal air quality. When we talk about industrial mortars, and Ecocork is an industrial mortar, we cannot forget that, using these aggregates, which is a 100% natural lightweight aggregate, we are focusing on the thermal performance of the buildings, on the acoustic performance of the buildings, so mainly to aerial sounds and reverberation, and also the durability. So three key factors that play a big role when we are developing a new building or when we are looking at the refurbishment or a rehabilitation of a building. This represents costs. This represents a view at long term in terms of what we have to do in terms of maintaining the building. So when we look at mortars and products that have a high durability, that have a high resistance to freeze-thaw cycles, to temperature amplitudes, and to presence of salts, for example, we are looking at a high durability and low necessity for rehabilitation or for maintenance. Of course, in terms of building a sustainable future and looking at the Ecocork systems and mortars, we really have to focus on the environmental concern that motivated us to investigate and develop these mortars. So when we are using a lightweight aggregate and a renewable aggregate, 100% natural, we are reducing roughly 80% of the volume in terms of consumption of non-renewable aggregates. And we are using long-lasting products that contribute to an increased life cycle of the buildings themselves. An increased concern also is now the analysis of different products that put together make systems, and applied they involve a building, or they are the let's say the code of the building itself, or even if we're talking about interior insulation. So we need to focus more and more on the life cycle analysis of the products as a system, and then the building itself. So this is definitely an issue that more and more companies are focusing now, and more developers and architects are focusing now. Of course, the technical concern, which has to be hand in hand with the environmental concern. So it's what? Improving the thermal performance of the building, improving the dynamic behavior of the solutions applied. So we want solutions that have a good energy storage capacity, and thermal delay. Thermal delay is one of the points I would like to focus more when I talk about insulation mortars with cork, and the cork insulation itself. Because cork has an increased mass, you can compare lambdas, you can compare thermal conductivity, you can compare thermal resistance, but there is a factor that plays a big role, which is the thermal delay. Usually insulation materials which have a lower mass, they don't have a very good thermal delay. So the time it takes for a temperature to get to point A to B, that it's crossing an insulation, it's more quicker than an insulation that has a higher mass. So this is also an important thing to focus. Sound insulation, we are talking about aerial sounds and reverberation. So either we are talking about high frequencies, medium frequencies. So insulation, cork is a very good insulation material for aerial sounds and reverberation to these frequencies. And also we are talking about mortars and insulations that have an exceptional water vapor permeability. So let's call it breathable products. High durability, freeze-thaw cycles like we discussed prior, and also the increase deformability, or let's call it the elasticity modulus. It's usually very low in these mortars that use the cork as an aggregate and use the NHL as a binder. Okay. Now, specifically about the products, we talked about the concept, and now we go to the products, to its application, and to the advantage. We are now looking at the buildup, and let's imagine a buildup with a stone masonry wall, a refurbishment, a rehabilitation. So we are looking at several steps in order to rehabilitate or renovate this facade. So first, we have to look at the substrate. We have to look at what it's there. We have to make it a solid substrate to receive the solutions. And sometimes we have to do some kind of consolidation. For that, we suggest a consolidation mortar based on NHL that sometimes has to be reinforced with a fiberglass mesh in order to consolidate and reinforce the substrate. After this consolidation process, we now have the layer that will serve as the thermal insulation and acoustic insulation, which here we use the Ecocork line, which is a NHL-based thermal mortar with cork aggregates, which can be applied around 40 mil up to 60 mil thickness tops. Of course, in several layers, hand applied or even sprayed with a spraying machine. In terms of finishing, we have different types of finishes, but I would say the most usual finish, it's the Rehabilitacal AC, which is a plaster. It's a fine plaster, around 3 mil application total, with a fine sanded finishing, very nice fine sanded finish, which is applied usually in 2 layers with a fiberglass mesh with 160 grams per square meter. And this would be completed with a silicate-based paint scheme. It's a 100% silicate-based paint, characterized by its high breathability, high vapor permeability, and high durability. In alternative, we may have, and because it's very, very usual, we may have the use of the Rehabilitacal AC in color. So we also supply it in a specific color that after would have to be protected with a water repellent agent with also high breathability to not have a negative impact on the solution itself. So this is the basic solution that we promote for the Ecocork line. Of course, there can be variations depending if you are working internally or externally, but for that, I would suggest you consult our technical services. In terms of the Ecocork line, as I told you, this is a lightweight mortar. It represents a lower consumption mortar with a high thermal capability and acoustic insulation. So it's made exclusively with natural hydraulic lime, and because it uses the cork as an aggregate, it has an improved sound insulation that can go up to 7 decibel in terms of noise reduction to air sounds. High durability, optimum workability, the possibility of being sprayed or hand applied, and with a very good salt resistance capability. Okay, this is supplied in 14 kilo bags. It's quite light, and the consumption is roughly 6 kilos per square meter per centimeter. This mortar is certified according to the standard 9981, and it's a T1 class thermal mortar for thermal insulation. In terms of finishes, as I discussed, there is a possibility of using a colored finish or using a silicate-based paint. These are our range of colors for the lime-based finish and the protection with the water repellent agent to prevent water absorption, too much water absorption from the mortar itself. This, of course, we have several references. This is an example in UK, typical southwest coast building where we use the system that I explained here. Okay, now we go on to the external wall insulations, the ethics, and I would start with first an explanation according to the definitions of ethics. I start here because this is an open webinar, so we may be speaking to people in Europe, in North America, in Japan, in several countries, in Spain, in France. So there are several definitions for what is an ethics. An ethics is a definition that is used by European Union and IOTA for the certification of the systems. But for example, if we go to England or United Kingdom, so it's mainly referred as external wall insulation or internal wall insulation. If we go to France, they have a definition by isolation thermique par l'extérieur. And if you go to Spain, you call it SAT, Sistema de Isolamento Térmico por el Exterior. If you go to North America and United States, it's an IFAS, Exterior Insulation and Finishing System, okay? But it's all the same. The definitions are different, but we are talking about the system. So we are going to call it ethics across this presentation. So external wall insulation composite systems. The concerns that we have regarding the application of these systems, and I think it's the main where we want to focus. It's if we have the external application, which is what in the first the system was developed to, but we have several countries where, because of the type of architecture and the type of buildings, the only way possible to increase the performance of the buildings and to improve the internal comfort of the buildings is to do the internal insulation. There are downsides and there are good sides of these two approaches, but sometimes you have to try to live with it. And of course, the internal application represents usually a loss of internal area. Everyone knows that you are increasing for 40 mil, 50 mil, wherever. But it's also, in terms of the thermal inertia, you will have usually less thermal inertia. And sometimes if you are renovating a building, you also have to do something on the external facade. This is, of course, a good way to do it. And the key factor is how to choose the insulations or the mortars or the systems. In the external application, okay, it maintains the internal area. It protects the building in a better way, of course. We are protecting the structure, we are improving the thermal inertia, and we are renovating the facade. In terms of the concerns that we have considering both applications, one of them, or the first, would be the superficial and interstitial condensation risks. So for this, we need to evaluate if the application is interior or exterior, and we need to evaluate the type of insulation, mortars and finishes that we are using. Because, for example, if we're going for internal insulation, depending on the insulation, depending on its breathability, depending on its behavior, we may have, depending on the region, we may have the risk of interstitial condensation. And this can create a problem in terms of internal air quality and other pathologies. So the other concern would be, as I said, the location evaluation. So we have to evaluate, depending on where we are, relative humidity, the yearly average temperature of the area, exposure factors, if it's northern facades, if it's close by the sea. All those things play a factor in terms of the system and solutions you are using. Ideally, the more breathable the system is, the better, and the lower water absorption the system has, the better, of course. And for that, we have to consider the building itself. We have to consider the probability of having rising damp issues. Most of the buildings, even new buildings, unfortunately, they don't consider an horizontal barrier, something that prevents the moisture from going up by capillarity. And when we have the issue about rising damp, we will have problems in the interior and the exterior. So here we have to create ventilation. If it's possible to create ventilation in the exterior, that's good. But sometimes there is no possibility, and we have to use systems for rendering, for facades, or for interior insulation that are breathable, and they promote the evaporation of this damp. We also have external factors like wind and rain. This creates an issue in terms of the system used, because if the system is highly absorbent in terms of water, this has a negative impact. And also we may have condensation in the interior, because the increased pressure on a building, depending on its use, you are creating more internal pressure. And if you have something sealing the internal wall or the external facade, you will have condensation issues, and then pathologies like black mold and other things. So we have to think about the building itself, the fit for purpose. So what will be the purpose of the building? If it's going to be for living, for working, an office building, if it's going to be well ventilated. Even if it is a private house, the ventilation of the houses is a key factor to prevent many pathologies. It's not only the system itself, the insulation systems that have to play the role. The ventilation needs to exist. Also, another thing I would focus is the water absorption of the mortars and the insulation materials. We can see here that the more water absorption our systems have, the lower R value the systems have, or the higher lambda value they will have. They will be more conductive. What this means is that if you think about a system or solution that has a good lambda, a good insulation value, but if that system has a high water absorption, the lambda, the conductivity, may vary a lot, around 40 to 50%, which represents a hugely increase in conductivity and a high decrease on the thermal resistance. So this has to play also a big factor. We know for a fact that, for example, Cork, in terms of lambda or conductivity, increases around 4 or 5%, but there are other materials, insulations, that because of their high absorption, they can increase up to 50% in terms of the conductivity. So this has to play also a big role. And the last but not least, we are talking about vapor permeability. And I take the example of the near zero energy buildings. One of the demands is that in terms of the insulations, the equivalent air thickness diffusion should be below 4. We are talking about issues regarding the ST value, which is the measure of how much resistance to moisture diffusion the material, the barrier has when compared to a meter of air. So this unit is measured in meters, and I show you here the comparison very quickly with expanded polystyrene, extruded polystyrene, and expanded cork. So you can see that EPS, by definition, it has some breathability. XPS, it's closed pore. Usually, it's an insulation used even to apply ethic systems on buried walls because of its closed pore. But because of its low capillarity, the breathability, the ST value is very high. The expanded cork, you can see it's around 2.95. And the cork is considered to be a low absorbing material, but high breathable material. So this is also a very important aspect. In terms of the systems, the buildups, very quickly, the Izovit cork system, which is the ethic system using the cork board and NHL mortars and silicate-based paints, is now certified, or in terms of ETA, of technical assessments, certified for substrates like blocks, ceramic blocks, also concrete, and we have a specific ETA also for wood substrates. Okay, so this is a very important issue, something that is very traditional in several countries, the use of timber frame with OSB or cross-laminated timber buildings. It was very important for us to have a specific solution and system that could be a perfect match between this wooden construction and the solution itself, okay? This, in terms of application, uses for the fixing of the boards and the leveling of the boards, a mortar with NHL and cork, grinded cork in the interior. It's also a lightweight mortar with low consumption and a high yield on the job site, very easy to apply. And also in terms of the finishing, as discussed before, and similar to the Ecocork lime system, we use the Rehabilitacal AC that can be natural color or colored, or even we can use the AC Pure. AC Pure is a similar product, finishing NHL product with a fine sanded look, but it has photocatalytic properties, which give him a self-cleaning property and air purification. In case of the use of AC Pure, there is no need to use water repellent agents, but if you use the Rehabilitacal AC in color, you should use a water repellent product, which here, the AD40, the product we supply, is a polysiloxane-based product with a high breathability and very good protection against water absorption. In case you are using the lime-based finish in natural color and you want a paint to improve also the durability, we have the Isovit Rev SP, which is a 100% silicate-based paint, or if you want a finishing with some grain size, we have the Rev SL, which has as a binder silicate. It's a silicate-based product, but it has also a grain size between 1.2 to 1.5 millimeter. It comes in a paste form. For interior purposes, we can also use, because we are talking also about thermal insulation in the interior, and usually the smooth finishes are the most required by architects and by owners. So we have the possibility of applying AC Fino, which is a very smooth NHL plaster for internal application, and in some cases could be used externally, depends on the regions. This is an example, but this is southern of Europe, and it's working very well. For some of you, this is nothing new, but the step-by-step application of an ethics system, considering that your substrate is a leveled substrate, a cohesive substrate, you usually apply the boards with the adhesion mortar on the back of the board, spreading the mortar completely on the back. Sometimes if you have uneven substrates, considered uneven, it's less than 1 centimeter with a 2-meter ruler measuring on the substrate, you can apply the board glued by points, and then you apply it directly onto the substrate in the corrected way, like you would apply a wall, like you would put in a wall with the bricks or blocks. So you have to make sure that the joints are not connecting in order not to create problems in terms of durability of the system and creation of higher tension areas for cracks and micro cracks. So after we have the process of the mechanical fixing, depending of if it's a concrete or block substrate or a wood substrate, you would use different types of fixings. You would have to reinforce all the special areas, mainly doors, windows, corners, dripping profiles, or even window sills elements to prevent also cracks on the finishing layer. Then you would apply the first layer of Isovit Cork, introduce the fiberglass mesh, the second layer for leveling, and then the Rehabilitacal AC finish or AC pure finish. So this is the finishing to give it the fine sanded look that can be used already colored or then painted with a silicate-based paint or a paste based on silicate, like I've showed you earlier. Don't forget that the problems that we find on ethics systems are mainly due to the poor treatment of special details. So we have to look, of course, at the starting profiles, the spacers and connections between the starting profiles. We have to look at window connection profiles, the corners and dripping profiles, window sills, and also the copings in the roofs. So all of this is to prevent, first, water from getting in between the connection of two different elements, water from getting in from the top of the system, and water from migrating from above. So we have to have this in our minds during the prescription of these systems. In terms of some references, I can show you some references that go from Portugal. External wall insulation. This is an example of 18,000 square meters we did in a social neighborhood. This was an European Union funded project that required a sustainable solution, and it really increased the conditions of living of the people that were living here, that had a lot of problems with insulation, thermal insulation, but also a lot with acoustic insulation. So this was one of the projects. I can show you also another one in Ireland where we did the rehabilitation in the interior of an ancient courthouse transformed into a school. These were roughly 2,000 square meters, and we had to do also some repointing, repair before the application of the system. We had to do also some execution of some samples for approval of the construction company, of course, and also interstitial condensation analysis. This is very important when we are doing internal insulation. So we found out that it was not new to us, but that there was no interstitial condensation occurring, because any condensation usually generated was very quickly evaporated between winter and summer months. So it was an interesting project. A lot of details, a lot of concerns in terms of durability that we supported also. And I think in the end, the project went very well. Also, when I say support, not only from the manufacturers, but support in terms of technical support, as I told you, we have European technical assessments for the Isovit Cork system, and also for the Isovit Cork wood system, which is for the wood substrates. together with some details that we supply for the correct application of the systems. Specifically to UK, we have also LABC certifications for external and indication of the system itself. Okay. Now, I would like to show you a variation of the system, which is the Isovit cork skin. And as the name says, it uses a high-density cork board to work as a cladding system, as a finishing system. So this is an interesting approach to the system, where we also tested the performance together with a mortar we developed based on NHL and cork, but with a higher resistance to water and with a higher adhesion. Why? Because the boards applied to the Isovit cork system, the high density boards, they are only fixed with the mortar by double bonding. So we have to make sure that any water migrating through the joints of the high density cork board arrives to the mortar and doesn't migrate to the substrate. For that reason, we developed several testings with the buildups of walls, where we measure the determination of the resistance to the rainwater, pulsating rainwater, and air pressure. So we found out that there wasn't any migration of water. There wasn't any problems with high pressure also in terms of the detachment of the system. So this is something that we are very comfortable. Of course, following some rules, which are mainly disconnecting all joints between the first layer of standard cork from the second layer of standard cork. Also, for this system, we have some very interesting references that go from Italy, with some architectural approaches, different approaches regarding the use of these systems, which I think they worked very well. In Portugal also, in Spain, in containers or in wood houses, or in connection with other materials like concrete. So we can have different approaches to these systems, which are sustainable, natural systems, and go hand in hand with not only traditional ways of building, but also new ways of building. Now, I thank you very much for bearing with me. I think we passed a little bit of time, but we started also, I think, 7 minutes later. And we'll have roughly 10 minutes now for some Q&A, so question and answers, which we have been receiving by written. And I will try, at least in the next maybe 7 minutes, I will try to answer as much as those. And the ones I don't manage to answer, I will do it by email, or feel free to send me by email also. I will, in the end of this session, leave one of the slides with all my contacts in the end. So we have a question from Benny, saying that I talked about life cycle analysis and carbon footprint, if our company have reports about the products and their impact. Yeah. So at the moment, the life cycle analysis that we have is regarding the NHL. It's definitely more and more not a trend. I think it's a need. It's a need for these systems. So we are now looking in terms of doing the life cycle analysis for specific products, and then together in some specific systems. So at the moment, the only life cycle analysis we have is for the NHL as the binder, but the next step definitely will be doing it for specific products and systems that we feel that will have the need to be assessed in terms of the analysis of the cycle of life in the building. So I wouldn't say we were going to do that for all products, but at least for these more sustainable solutions and thermal insulation, usually solutions that are like the sacrificial systems and solutions in a building. We have another question. In Holland, the building passport is becoming more and more common. This also includes recycling of the components and the building end of life. Do you have information for your products on this matter? I think this passport probably is connected to knowing the life cycle of a product of a system. So I would say that is in connection with this. We know that in Portugal we are not there yet. We are in countries, where the concern regarding the building lifespan and what happens to a building after its lifespan and the use of the materials removed or from that building. But I would say that we are in one of the first steps, which will be the obtaining of the life cycle analysis of the solutions. Okay, another question. You talk about the use of wooden substrates. How about prefab? Is the building able to hold when moving building parts? Okay, from what I understood, okay, look, probably you are talking about prefabricated houses, mainly light steel framing. We know that for a fact that light steel framing, but I would say the cross-laminated timber would be more resistant. But timber frame with OSB or light steel framing, I think in terms of movements, I believe the movements will occur. So what I can do to prevent my systems from sometimes cracking or having some pathologies? Using systems that have the possibility of having some flexibility, and for that I have the finishing mortars, adhesion mortars. And when I talk about lime-based mortars with cork, I'm talking about that. I'm talking about some kind of adaptability to the building movements, to the slight movements of the structure, and how the system itself can accompany that without having those pathologies like cracks, micro cracks. And I believe, for example, the Isovit Cork system or the Isovit Cork skin system are very excellent solutions to prevent those pathologies in this type of specific structures. I think it's the last one. Okay, can the mortars handle water as liquid as well as vapor? Okay, we are talking, hygroscopic issues. I would look at this as a system, and yes, we have been doing several tests with immersion in water, several tests with sulfate aggression, and several tests with freeze-thaw cycles. We found that our premix mortars, and I'm talking about industrial mortars. One thing is to do NHL 1-2, 1-3 with sand, with different types of sand, but of course, in an industrial mortar, we have also the additives. We have air entrainment agents that make it more flexible, that make it more breathable without compromising the capillarity. So I know for a fact, for the testings we've been done, that the reaction to water in liquid form and vapor, we have a very good compromise between these two factors, which is external or internal factors like high internal pressure or high winds and rain, and the absorption of the system itself. So I would consider that these systems answer to those challenges in terms of durability. So I hope my answers were clear. I hope you enjoyed this webinar. We certainly did. I hope to hear from you soon. Let me just share my contacts here in the end, just for you, in case you want to take note of my email, and in case you want to place some other questions or doubts, feel free. I'm available to answer any issues or doubts that you might have. And I hope you've enjoyed this webinar and hope to see you soon. Thank you very much for registering, and thank you very much for your presence.